Alright, we're going to talk about logarithmic functions. And logarithmic functions are inverses of exponentials. So they'll share buttons on the calculator, and we'll get to talking about that later. So log base b of a positive number satisfies the following definition. Y equals log base b of x is equivalent to b to the y equal to x. Now the way that I think about this, y equals log base b of x, is that the b comes around here and knocks that up into a exponent, and then you're left with x. So that's how I remember to go from one form to the other. We read this log base b of x, or the logarithm with base b of x. I don't know anyone who says that, because that's a lot more to say than just log base b of x, or log b of x even. The logarithm is the exponent to which b must be raised to get x. Since log and exponential functions switch the x and y values because they're inverses, the domain and range of the exponential functions are interchanged with the logarithmic function. Therefore, the domain of a logarithmic function with base b is 0 to infinity, and the range of the log function with base b is all real numbers. You'll have two special logs. We'll get into this later, but if you see log of x and there's no base, it is assumed that it's log base 10 of x. And if you notice, if you ever forget, on your calculator it says just log, but 10 to the x, it's because I said inverses share buttons, so 10 to the x is its inverse, so it has a 10 in it, so that's how you can remember that. And then natural log, the natural log of x is really log base e of x, and we'll I think talk about e soon, but there's the natural log here, and its inverse has an e in it, so that's how you can remember, just by using your calculator if you get nervous. Okay. Can we take the log of a negative number? No, because the base of an exponential function is always positive. No power of that base can ever be negative. We can never take the log of a negative number. Also, we cannot take the log of 0. Calculators might output a log of a negative number when it's in complex mode, but the log of a negative number is not a real number. I've never had my calculator in complex mode. But if I wanted to try to take the log of negative 5, it's going to say non-real answer, quit, or go to what. So you can quit, or you hit go to, and it'll tell you what it has a problem with. So to convert it, we're just going to take this, identify b, y, and x, and rewrite it as b to the y equals x. So here, b equals 6, y is 1/2, because the square root is the same as 1/2 power, and x equals -6. So we rewrite this as, you can plug those in. Remember, I said that I think of this as this coming around here and bumping that up, so that becomes 6 to the 1/2 power equals the square root of 6. And that's a true statement, because the square root of 6 equals square root of 6. But they want, I took it too far. They just want you to have that. So here, I think about this, bumping this up as an exponent, and I get 3 squared is equal to 9. To convert from exponents to logs, we follow the same steps in reverse. We identify the base, exponent, and output, and then rewrite it. So I have 2 cubed equals 8. And that would, so remember this was the base, so log base 2 and of 8 is equal to 3. Because remember, this brought this over here, bumped that up as an exponent, so that checks. This was the base before, so this is log base 5 of 25 is equal to 2. And then this is log base 10 of 1 over 10,000 equals negative 4. And technically, you don't have to write the base 10. That's convention. Alright, evaluating logs. Knowing squares, cubes, and roots of numbers allow us to evaluate many logs mentally. For example, the log base 2 of 8, we asked what exponent 2 must be raised to in order to get 8, and because we already know 2 cubed equals 8, it follows that log base 2 of 8 equals 3. So we can go through these examples and see how we do it mentally. Given a logarithm of the form y equals log base b of x, evaluate it mentally. Rewrite the argument as a power of b, and then use previous knowledge of powers of b to identify y by asking to what exponent should b be raised in order to get x. So if I want to solve this mentally, y equals log base 4 of 64, we would say 4 to what power equals 64. Now let's see, let's look at 64. It is, if I divide by 64 by 4, I get 4 times 16, and that's 4 times 4. So that's 4 cubed. So y equals 3. So this is kind of, I jumped the gun earlier telling you about the other logs that are on your calculator. If you have log with no base, it's equivalent, it's log base 10, and it's equivalent to 10 to the y equals x. So it says evaluate log 321 to 4 decimal places using your calculator. So I have I have a picture of it on the next page, but let's go ahead and we're going to hit log 321, enter, and that gives me 2.5065 because it said go with 4 decimal places, and I have it here, how to squish it a little bit to get it in on the page. But so I would write equals 2.5065. And back in the day when I was in school a million years ago, we had log tables, so math books were twice as thick as they are now, and we would have to go to the back and look at the log base of something, and most of those tables are 4 after the decimal point, or we'd use CRC manual as something else. It basically was our Google in a book, and we would carry it around and do our homework with that. Alright, using natural logs. Okay, so natural logs are used a lot. They are log base e, and we use its notation ln of x. Most values of natural log of x can be found using a calculator. The major exception is that because the log of 1 is always 0 of any base, natural log of 1 equals 0. For any other logarithms, we can use the natural log key that can be found in most scientific calculators. We can find natural logs of any power using e with the inverse property of logarithms. So since this is the most important here, y equals e to the x and y equals natural log of x, they're inverse functions. So if you take the natural log of e to the x, you just get x, and e raised to the natural log of x gives you x. So the natural log and e to the x undo each other, Actually, all inverses undo each other, and you remember they share buttons, so that's kind of how you remember that. So given a natural log with the form y equals natural log of x, you evaluate it using a calculator. So I'm going to do evaluate natural log 500. So I'm going to hit natural log, type in 500 in my parenthesis, and I get 6.2146, and it says using 4 decimal places, 6.2146. Alright, that's all you need to know about that. There's more videos if you want to learn more.